Hello, fellow Java developers. Welcome back to our Making an Example of a Real-World Camel Application series. In this video, we will add an HTTP endpoint. For that, we will use Camel HTTP component, and we will also use Camel marshalling and unmarshalling capabilities, JSON parsing libraries, and much more. Let's begin. Before we continue working on our application, let's go through what we already have. Here is our POJO, where we have this dependency management section with Camel Spring Boot BOM and Spring Boot dependencies, and below we have all our Spring and Camel Spring dependencies specified. For now, we have only one route that reads file from an SFTP server using username, password, authentication, and checking known hosts file. Then it moves the file to the processing directory and processes it by parsing file name and then saving the status of read document to the PostgreSQL database using the information from parsed file name as document ID, owner ID, etc. And lastly, it saves the ID of inserted row here in this database log ID header. Our parsing file name logic specified in this parse file name method that accepts exchange is pretty simple. Our file name is delimited by underscores, so we just make use of split method. And in our integration and unit tests, we check that our application works as intended. In integration test, we make use of test containers, specifically SFTP container with Atmos SFTP Alpine image, and PostgreSQL container with Postgres 17.2 Alpine image. And in the test itself, we send our test file to local SFTP server started in Docker container, and then we check that the corresponding record appeared in the database. And in the second test, we do the same, but our file name is invalid, and instead of checking that the log appeared in the database, we're checking that the file appeared in error folder. And finally, for our unit test, we're mocking all the endpoints that our route has, and then in the test itself, we just send some input message and verify that our route does all the steps specified. It calls this parse file name method, it sets header, sends message to this SQL endpoint, and again sets header. Now, let's go to our requirements and documentation file and see what we need to do next. As you can see from our data flow schema, after we've read the PDF document from SFTP server and logged that fact into database, we need to send signed document request to signed document service via HTTP and get a response. And again, the status of the processing should be saved in the database. This is what we will do in this video. We will look at more specifications later, but for now, we know that we need to somehow construct a JSON request, send it via HTTP, and parse a JSON response. This is enough for making a draft of our camel route. So let's go back to IntelliJ, here it is, and create a new route. We will call it sign document route, because that's what we'll be doing here. And when we've done that, let's actually rename our previous document read route so that we always have the same order of verbs and nouns. And when we've done that, we can right away copy this route ID and rename it to sign document route. Then we need to specify that our route should extend route builder, generate method, And here we need to start our route from somewhere. Well, logically, this new route should start from here, because this route does not write the resulting message to any external system. And what we could have done is we could have continued defining our data flow right here in the same route. But it is better to split your integration logic between different routes, because smaller routes are easier to read, easier to test and debug, and even scale if the need arises. This is why we will make a separate route for each of the systems that we're interacting in our data flow. One route for reading the document from SFTP server and writing to the database. The second route for sending signed document request and receiving a response, and again logging that fact in the database. And the last third route will be for communicating with client send service and making a final log in the database. So to make our next route read from the end of our previous route, we will make use of direct endpoints. Let's call our direct endpoint constant as route start, and here we will just specify our route name, and our route will be reading from this direct endpoint. And of course, our previous route should be sending its results to our next route using the same direct endpoint, which is accessed through this public static final string route start field. And right away we can specify our ID of the route. And now let's consider the next steps. First, what we should do is somehow construct a sign document request JSON. Then we need to send it via HTTP and get a response, and then we need to parse this response and log the results to the database. And of course, finally, we need to, same as in our first route, send the results to the next route, which we do not have yet, but we will make it soon. So let's approach this step by step and start with constructing sign document request JSON. Let's go to our documentation. Here it is. And here in the document signing section, we can see that the request JSON is pretty simple. It has just 5 fields, 2 of them document ID and owner ID. We read from our file name. Then sign type and API key should be configured through application properties of our application, and the document type is taken from our parsed file name. So there are several approaches to constructing this JSON. Let's go back to our IDE and look at these ways. First and the most simple way is just using setBody DSL element, and with simple language we can just construct a JSON string, something like this. For example, here we have a JSON with just one field, which is document, and the value of that document JSON field is provided by our message body. But this way of constructing JSONs is suited for the most simple JSONs only, because you can imagine how cumbersome and complex this string might become if you have several fields and some fields have an object or an array type themselves. This can get very long. So we will not use this way of constructing JSON, but we will construct a Java object instead. When constructing Java object that will be marshaled into JSON string and sent via the network, we again have two options. First thing that we can do is we can construct an object that represents JSON and defined by some JSON library, for example, Jackson. It has, as you probably know, object node, class defined, and we can construct that object node to be sent as our JSON. But this way is for the cases when we for some reason want to work on the level of the library itself. What is the most simple and flexible way of constructing our requests to be sent via the network is making a Java model classes and describe our message format inside them. I've created the document sign request class that will represent our JSON request. Now I will add all the fields that it should have. And now we can use IntelliJ to generate all the constructors, getters and setters, equals and hash code, and even toString method. Let's generate it. We could have used Lombok library, but we will not have too many of these model classes, so Lombok will not save us that much time. That's why we're not using it here, but of course you can use it. In this project we will not use aspects or any kind of reflection on these classes, so we can use Lombok safely. Now, when we have our request class defined, we need to somehow construct an instance of this class. For that, we need to call some form of bin. Here, what we can do is we can make use of our exchange transformer class and just define another method. For example, something like create document sign request. And again, get our message from the exchange, create the document sign request, and then set it as our message body. But what might be better to do instead is make a separate class for that. I'll explain why in a second. As you might remember from our documentation, here we have these two fields that should be configured from our application.properties. Now, if we have one class that is used by all the routes, then for each route tests, we would need to initialize these two sign type and API key properties with some stub values. But we don't want it. We want to separate the test values. We don't want our test to specify values that they don't use. This is why we are making a separate class for making a sign document. Now let's make the method that creates a Java object itself and will be called by a route. For that it should accept an exchange, and here what we can do is extract a message from our exchange, and then for that message we can call setBody and pass our object there. Let's actually rename its class so that it's consistent with the documentation. And let's actually rename our class to sign document request mapper. And let's rename this class so that the naming is consistent. And here we can create a new object and pass it to our setBody method. Now we've done almost everything. All that remains is to pass all the parameters to the constructor. As our first parameter, we have our document as base64 string, so let's use Java util base64 class and encode toString our input message body, because at this stage our message body is not set to the result, which means that here our message body will be our PDF document contents. Now the next field that we have here is owner ID, so to get it we can use getHeader method and pass a constant from our exchange transformer class. Here it is, and the next value will be sign document sign type. Then we will have sign document API key, and the last value will be document type, which we can again get from our header. Now we've done almost everything. All that remains is to specify this sign document, sign type, and API key that, as we've said, should be configured through our application.properties. For that, we can make use of Spring value annotation, and with declaring this as private final, we can add them to the constructor. And here, let's actually specify value, and the same for the sign document API key. We'll get to our application properties and set these values in a minute. But for now, we need to actually specify a class of these header values so that they are extracted normally. And now we can go to our application.properties and set up our values. Actually, our application.properties is starting to have a lot of entries in it. So it will be more convenient to make it application.yaml instead. I will edit out this part. And here we have our application.yaml. It's the same as application.properties but in different format. And here I've added this sign document section with two properties. First one is sign type, which is CADESC, and the second one is API key, which will be configured through environment variable. So with that, we can get back to our sign document request mapper and fill this value annotations. And with that, our sign document request mapper is ready. Now that we've decided to use one service annotated class for each separate route, let's also rename our exchange transformer to file metadata extractor. And when we've done that, what we can also do is we can get rid of this parse file name method parameter, because now we are sure that our class will always have only one method, which is this parse file name accepting exchange, and Camel can bind it automatically. So in our route, let's make private final sign document request mapper, and as we have a Spring application and we've annotated our sign document request mapper as a service, it will be auto-wired here. So we can just specify it again without passing a method argument to this bin DSL element, because we have only one method in our sign document request mapper, which means that Camel will bind it automatically. Now let's just log our request and the fact that we're about to send it to the sign document service. Let's actually edit it a bit so that it is more clear. Here we will provide our file name, then on the next line we will provide a body. So here we need to specify header and close that bracket. So our log statement will be look like that. Sending document, this will be changed file name of the file that we've read because of this simple expression. And here it will log our sign document request object, which has this toString method overridden, which means that we should see our object's fields. Now we've constructed our request object, but we need to actually send it in JSON format. As you might know from our translating messages video of the Apache Camel for Starters playlist, this is done with Marshall DSL element, and here we're just specifying a format which we want our output to be in. But for this configuration to work, we need to add a library that would do the actual transforming of our object to JSON string. Let's go to our POM XML, and here with other Camel dependencies we can specify Camel Jackson. starter dependency. Let's download it. This dependency provides JSON library that will be used by this marshal.json DSL elements to parse our message to JSON. And actually, while we're here, what we can also do is we can add camel HTTP starter dependency, because the next step after we've transformed our object to JSON is to send it via HTTP. So with that we can delete this comment because we already done constructing a JSON, and here we can specify two DSL element and provide our URL. Now, of course, our URL, same as any other connection detail, will be specified through the environment variable. So let's add it to our application.yaml, and in our route we can just use the variable, and because the URL itself will be containing this HTTP part, I will just delete it. Camel will recognize it automatically. And that's it. Yes, making an HTTP requests in Camel is that easy. Well, of course, this configuration has some issues, like what will happen if this docsend signed document URL environment variable will be set to something else than HTTP URL. But we will address that later. For now, we just want to construct a base of our route and make sure it works as intended. So we leave it at that. Now, what we need to do is we need to parse the response. For that, let's go to our documentation and see what does the response contain. As we can see here, our response has a simple JSON format, pretty much like our request. It has the signed document field with base64 encoded PDF, then it has status, message, and a timestamp. So let's return to our IDE, and same as with our request, we want to have a class representing our response. It will be created in the same manner. I will edit out this part, and here we have it, our signed document response class, which is the same as a request, just a plain old Java object with value fields. And as you probably guessed, to parse our response to that class, we just need to provide a class name to our JSON DSL element. And with that, we're almost done with parsing the response. You see, if our response was containing only primitive fields like strings, numbers, etc., we would have been done here. But as it contains this local date time field, we need to do a few extra steps. You see, our JSON starter library that we've added to parse and unparse our JSON does not support parsing timestamps to local date time out of the box. What we need to do for it to support the parsing is we need to add this JSON data type JSR 310 dependency. This is the extension of a regular JSON parser, which makes it capable of parsing timestamps to Java local datetime type objects. Now, that's not everything we need to make it work. This JSON parser extension should actually be registered in JSON object mapper. In a regular application, we could have configured Spring configuration, then declared object mapper bin and configured this JSON data type there. But we have a Spring application, so what we can do is we can add Spring Boot starter JSON, which will auto-configure object mapper for us, and it will also automatically detect this data type dependency and registers it. We don't need to do any further configuration ourselves. All will be auto-configured by this Spring Boot starter JSON. Now let's download the dependencies, and the last thing that we need to do is to annotate our local datetime field with JSON specific annotations. Here we're specifying our serialization and deserialization classes that should be used to parse and unparse this field. And we need to use this JSON format annotation because by default JSON will try to split this date and time into two separate fields, one for date and one for time, but with this JSON format annotation we're making sure that this field will be written into one JSON field and it will also be read from one JSON field. Now we've done with parsing the response into our Java object for sure. Let's actually log the fact that we've received some HTTP response. For example, we can write that we've received the response and then log the body of such response. And after we've parsed our response into the Java object, we can use it to get, for example, the status of our document. As you probably know, simple language allows us to call methods of our body or header objects. So here we can just specify body.getStatus and our response status will be logged. The next thing we need to do is we need to log this status into our database. But here, instead of inserting, we will update our existing row. We will set status equals, let's copy this simple language expression so that we don't blunder anything, and we can use the same method call here. And let's also specify that our timestamp will be updated with current timestamp. And the last thing we need to do is specify our where clause in which we will make use of this headers DSL element. Then we will copy this database log ID constant because that's the name of the header that we've used to store our generated key. And here we have it. This is our SQL update statement. Now let's delete this database comment, and the last thing that remains to do is to send it to the next route. Let's actually create a class. We will not work on this route yet, but we will just create public static final string route ID, which will be the same as the name of the class. And we will also copy this direct endpoint and edit its name so that now we have some endpoint name to use for sending the result message that this route produces. And with that, we've configured the first version of our route. Now, before we go any further, it's better to test the route that we've just created. We've already tested our send document route, so we can test our new route similarly. We will write one unit test and one integration test. And for our new signed document request mapper service, we will also have a unit test in our service test package. And before I forgot, let's actually declare this class a component so that it gets automatically discovered and this route is actually run. So before we start writing our unit and integration tests, I would like to do a bit of a cleanup so that tests are easier to write. First thing that we need to do is we need to go to our POM.xml and we will add camel endpoint DSL starter, because now what we have in our tests is this kind of endpoints that are just specified as strings, and in our route they are also specified as strings, while it's better to have them as an endpoints. You'll see what I mean in a minute. As you can see, here we have our SQL insert string, and in our test we also have the same string when we specify which endpoint should be mocked. Now, if we make any change in our SQL query, our test will fail because the mocking will not happen anymore, because this endpoint will be different from the changed endpoint. To avoid that, it is better to have our endpoints as public static final constants, and as we've added our endpoint DSL, we can make use of that and just copy the URI here and then make use of all the methods. For that, of course, we need to import this SFTP static method. Now let's copy it here, and of course now it will be SFTP endpoint consumer builder, and now let's transfer our options here from our string URI to the new SFTP endpoint definition, and we need to add move, pre-move, and lastly move failed. And with that we've configured our endpoint, and now we can just specify this from SFTP endpoint and define the endpoint here. And when we'll be mocking or otherwise use this endpoint anywhere, we'll have only one place where it can change. Now let's do the same with SQL endpoint. Let's call it SQL log endpoint, because here we're logging our status to the database. Now we'll use an SQL static method, and here we can just copy this whole string. Let's actually put it on a new line, and now we can just use it here in this to statement, and in our unit test, instead of the string, here will be just get URI, and just to be sure, we will specify our route class here. Now we'll do the same with our sign document route, and now we have it. As you can see, instead of specifying our endpoint directly, we're constructing it here with this HTTP, or in case of SQL, well, SQL static method. And in our toDSL element, we're just using this endpoint builder constants. And when we need to mock them in our tests, we can just make use of these constants and be sure that if we make any change, we don't need to change the tests, because the endpoint URIs now have only one place where they can be changed. And this approach also solves our problem with HTTP application property, where we can pass anything, because before we had just this sign document URL, and you can imagine if we pass something like SQL : we can try to insert our sign document request to the SQL database instead of sending it to the HTTP. But now, as we have this HTTP method, we should get an error if we pass anything other than HTTP URL here in this property. So that's one more problem solved. Let's recap what we did to construct our sign document route. Here we make it so that it consumes from the direct endpoint to which the previous read document route writes. Then we've created a signed document request mapper bin, which creates our request object. Then we created a marshalling logic with JSON library, which is auto-configured by this Spring Boot starter JSON. And of course, we've added Camel JSON starter as an initial Camel dependency. Then we're sending to an HTTP endpoint, which has its URL configured through application properties, and we unmarshal the response by just specifying our response class, which is just a plain old Java object. And finally, we log our status of the database. With the help of simple language, we can just call this getStatus method of the signed document response object. And finally, we send the result to the next route. In the next videos, we will write tests for this route and configure an HTTPS secure connection. And with that, here is the end of our third video on making an example of a real-world Apache Camel application. Thanks for joining. Be sure to like, subscribe, and hit that bell icon. And if you have any comments or questions, leave them down below. I will answer to all of those. See you in the next video. Until then, happy coding!